review a little bit about derivatives. I'm going to teach you product rule, quotient rule. We are going to review chain rule. We're going to talk about the derivatives of trig functions. We're going to talk about the derivatives of natural logs, ln's. We're going to talk about derivatives of e's. And then once we are comfortable with all that, which I don't even know how that'll ever, what that will happen, we are going to learn two topics called implicit differentiation. Sounds horrible, love it. And then parametric differentiation. Sounds horrible, not bad. If you know how to take the derivative of ln's and e's and product rule, and so you have to have a comfortable, quiet confidence in the techniques, which is what we're going to practice in the beginning, and then we're going to dive in, and I'm going to teach you the technique. Are we cool?
Yeah.
Yeah, it was a good starting point. It's kind of waiting on Kaylin to get back so I can. She's like, "Can I use the restroom?" And I said, "Sure." And I don't want to. I know, I feel the same way right now. You're going to want your bright colored sheet of paper that is pure math. So that's the one you're going to want. Because a lot of the stuff that we're doing is on there, which is pretty cool. So I had a few people get on last night for A-level, and I started pre-teaching this, so I did a lot of it last night as well. So if today is like not sufficient, and you want to kind of go back and look at that, it's uploaded and ready to go, so that's kind of helpful. I learned the hard way that you guys don't like proofs, so I'm not going to I'll do one proof, but do you have to have a proof to be able to do it? No, but later in life you may want to use this, so no, I don't know, we'll see. Okay, we're going to go back to the old-fashioned power rule. So this is derivatives. Also known as differentiation. So sometimes that confuses people. I want to be able to use them interchangeably. We're going to find, the derivative of, or we're going to use differentiation. Just FYI, they mean the same thing. Sometimes that doesn't go well. So we're going to go back to last year. We're going to review the power rule first, with the hopes that you guys will naturally remember the power rule. Initially, you'll be like, oh, it's been a while. And then hopefully it'll start to become like riding a bike. You don't do it for like 6 months, but you get back on, you're like, oh, a little wobbly, and then I'm good to go. All right, so power rule is if I have x to the n, anything to a power, we are going to be able to use the power rule in order to take a derivative of this. So the rule states I take the exponent, bring it to the front, rewrite the x, and then subtract 1 whole. Thumbs up if you remember that. Yes, a few thumbs up, a few of them. Okay, good. So the power rule, as an example, let's say I have something like x to the third. Derive it for me. Another word I would use, derive. So go ahead and derive it and tell me what you get.
3x squared.
Absolutely. So this is like y, and this is like y prime. Do you guys remember the different ways that I could tell you to find a derivative? Like if I said if it's f of x, I could do f prime of x. If I say y, I could say y prime, or I could have written dy over dx. Does that ring a bell? Yeah. So those two ways are saying, hey, I did a derivative of. Okay, now, what happens when using the power rule if I have something in front? Like, for example, 6x to the 4th power. What does that 6 do? What do I say? What's the terminology I use? I just carry it forward. I always say you make it go for the ride. So I'm going to take the 6. I'm going to find y prime, make the 6 go for the ride, and then I'm going to derive x to the 4th. So using the power rule, what's the derivative of x to the 4th? 4x to the 3rd. And then you can multiply those two guys and make it 24x cubed. Are we cool? I haven't rocked anybody's world yet. Yes? No. Okay, good. I do believe I was wrong in my little lesson last night when I'm like, obviously I taught you the product rule, and then I was told that, oh, I never taught you all that. So I am going to go to the chain rule, which I think I taught you all. Yeah. Yes, I did. Okay. So the next one I'm going to kind of go over is called the chain rule. Some years I teach the product rule to Aice level, and some years I'm like, whoa, I think I'm just going to do these two. You don't utilize it on the test, so there's really no need to give you that more information that you don't need, but I will teach it to you today. I think y'all will be fine with it. So chain rule, I feel you guys are comfortable with. We've done it a few times over. Let's just review what it looks like. It's when we have stuff that's contained within, like I said, a parentheses, or to a square root, like a 1/2, or something that's in a denominator that I have to bring up that's contained, okay? So this is like a sampling of what you could utilize for our chain rule. Our chain rule says, take the n, the exponent, bring it to the front, and the terminology that's very professional that I use is to rewrite the junk on the inside. Does that sound familiar? Yeah, it's very professional. So we rewrite the junk on the inside, do not move it, do not change it, just rewrite that junk. And then what do we do to my exponential power? Subtract 1. And then there's one more step that most people do forget. It's like they look at this thing and they go, oh yeah, I have to take the derivative of that junk on the inside. And so what would the derivative of this be? I should have kind of reviewed that, but I'll talk about it. So ax plus b, the derivative of that would just be a. So let me go back and explain why, because the power rule comes into play here. And I didn't really do a good job reviewing that. So let's look at something like 3x squared plus 2x plus 1. If I have a string of things like this, and I want to take its derivative, I do them individually. So the first guy seems to be the easiest guy for most. 3x squared, its derivative would be 6x. Are we feeling okay about that? The 2 comes to the front, the 2 and the 3 multiply, I subtract an exponential power. So in the state that this is at, what's the exponential power for this guy here in the middle? 1. To the 1. So it's the same concept. It just gets a little wonky because people forget this. I'm going to bring the 2 for the ride. I'm going to bring that 1 that you all told me. And then what's my new exponential power going to be for my x? 0. What is anything to the 0 power?
1.
Just 1. So if we can recall from way back yonder, when I have 2 and x to the first power, the derivative is just going to be the value of the constant in front. So the derivative of 6x would be 6. The derivative of 3x would be 3. Okay, and the reason is because the exponential power becomes a 0, which causes that to be a 1. Now, moving forward to this guy over here, which I didn't review at all, I should have. If I have this, how many x's do I have here?
0.
I got 0, so it's really x to the 0 power. And so I make the 1 go for the ride, and then what's the exponent that comes down? It's a 0, and then I have x to the negative 1. And what do we know about anything that is multiplied by 0? It's 0. So the derivative of a constant is always 0. And let me explain why visually. If I have a constant, like for example, the number 2, if I'm graphing y equals 2, what does it look like with your arm? Y equals 2. Not that. Yeah, good job. Yeah, right there. All right. What's the slope of this guy here? How much fun am I having? Absolutely 0 fun, right? The slope is 0. So when we take a derivative of something, we're in actuality measuring the slope. Slope of 1, slope of 2, slope of 3, negative 1, whatever, is 0. So I know when I have just a constant, the slope is 0, that goes away. Are we cool? All right, so back over here, this guy, ax plus b, x is to the first power, so the derivative is the fact that the x goes away, I'm left with an a, and then b is a constant here. What would the slope of just a constant be? 0. So that's why this happened. I shouldn't have jumped into that until I went over that. It's been a minute though. All right, are we cool? Do we remember these? Yay, we love it. Oh, good. Nobody loved it, but that's okay. I feel like you do. Take a derivative of that for me. What's the first step you do to do the derivative of this?
Bring the square root into 1/2.
Beautiful. You rewrite the square root as a 1/2. Everybody remember that? Now we're going to use what rule? Chain rule. The 1/2 comes to the front. And what do I do? It's very professional sounding. Rewrite the junk on the inside. That's exactly what you should say. And then what do I do to my exponential power? Subtract 1 whole. And then what is the derivative of the junk on the inside? 3 times 3. I can bring it out front. I can bring it over here. I don't care. Do you agree? 3 could go there. It's multiplied, so it doesn't matter. So 3/2 times that. Feeling good? Okay, cool. So now the next thing you're going to do is we've now practiced the power rule. I went fast through it just in case you are like, whoa, we did it last year. That's why I kind of went fast through it. We also did the chain rule. Now we're going to learn something called the product rule. What does product mean? Multiplication. So when you have two items that are multiplied together, their derivative utilizes this thing called the product rule. I believe they use U and V on your bright colored sheet of paper. So I'd like you to find that under derivatives. Don't get confused with the integration section. U and V? Okay. So find it, know where it's at. It's under differentiation, all the way at the bottom. Okay, so let me go into great detail as to how this looks and then kind of liken it to what you have there. When I have two items multiplied, so if I have two binomials multiplied, what does binomials mean? Can you give me an example of a binomial? Like x plus 1, that's a binomial. 2x minus 3, that's a binomial. If I was multiplying those two together, they're totally different x's, but they're being multiplied. That's when the product rule comes into play. So you would call one of them u and one of them v. Let me explain what this looks like and then I'll give you examples. So u times v. The way you do this is so to find, let's say that this is y is equal to find y prime, we are going to take, and it looks a little different on there, I'll clean it up to make it look like that. The derivative of the first times the second plus the first times the derivative of the second. So think about it this way. I have two things. I'm going to take the derivative of the first thing times the original second plus the first times the derivative of the second. Okay, on a personal level, I think on your bright colored sheet of paper, they put the u and the v first. So if you look at it quickly, is that what it looks like on your thing? So commutative property of multiplication says that I can do u times v or v times u and they're the same thing. So that's what happened here. But it is the derivative of the first times the second thing plus the first times the derivative of the second thing. Okay? On a personal level, I prefer it to look like this. See what you think. So, do you see that it's the same thing? What makes it a little different is that I didn't put du over dx or dv over dx. I think it's easier to see primes, but that's just kind of where I'm at, okay? So the derivative of the first times the second plus the first times the derivative of the second. Let me do an example, because to me, this looks like, if I see it in action, it makes better sense to me. Do you agree that these two things are completely different things multiplied together?
Yes.
In the real world, we could FOIL it out and take a derivative of it and be good, but I want you to be able to practice this product rule, so we're going to leave it like this. I'm going to call the first one u. So I'm calling this first thing u and this second thing v. Just so you have a visual of which one is u and which one is v, okay? To be honest with you, I never rename them when I'm doing this. It just naturally in my head, I say, the derivative of the first times the second plus the first times the derivative of the second. And I don't worry about the u and the v, because to me that's just making it more complicated. So if I look at this, the thing says derivative of the first. So what is the derivative of the first thing? 2. Times the original second. derivative of the first times the second, plus the first, what's the first thing? 2x plus 1, times the derivative of the second. What's the derivative of the second? 3. In calculus, the calculus of this problem is 100% done. You've done the calculus, you've done the new thing that you had to learn, and now it's just algebra. So what you're gonna find in this whole lesson is you're gonna do one-step calculus and then a lot of algebra. What do I mean by algebra? What technique should I use for this piece here? Distribution. What should I do over here? Distribution, and then what should I do? Add them together, combine like terms, and you have your answer. So, distribution, combine like terms, and there's your answer. What do you think? Yay, no, maybe?
Is it only for binomials?
No. For you, yes.
Okay.
In reality, no. You can do the derivative of the first times the second times the third, and then make sure you cover all the derivatives. But for you guys, no, we're good.
We're not gonna use it.
We will not, but you can, absolutely. Okay, so let's say I have something like this, because I thought this was gonna be your question. Okay? So, do I have two totally different things multiplied by each other?
Yes.
So what rule would I use to do this problem? I'm gonna use a product rule, however, there's something else that's gonna come into play when I'm doing a derivative individual pieces. What's the second rule that I'm gonna utilize? Absolutely, the chain rule. Do you guys see it? So it's product rule with a chain rule inside. So let's talk about how that looks. The derivative of the first. So what do I use to take the derivative of the first? You have to use chain rule, right? Okay, so sometimes you have to kind of combine these. So what is the derivative of 3x plus 1 squared? Do it at your desk, I'll do it up here, make sure I'm right. Because it's kind of possible that it doesn't come out right for me. All right, how did it look to you all? The derivative of the first, feeling good? Times the second, plus the first, times the derivative of second. Yes, no, maybe so? Now, if the question says, take a derivative of, have you taken a derivative of this thing? Is the derivative done? Absolutely. If the directions say, take the derivative and simplify, then what am I looking to do? You're actually trying to combine like terms and FOIL it out and make it beautiful. However, the calculus of this problem is done. You don't necessarily have to clean it up. Okay, unless I specify, make sure this looks good when you're done, clean it up, your derivative is done. So, I mean, you could do a little bit of cleaning action on it, however, you don't have to. Well, I dropped my plus. You don't have to, okay? It just depends on the problem that you're working on. If you were indeed simplifying this thing, what would you do? You would probably FOIL this out, right? First, outer, inner, last. Take the 6 and distribute it through, and then what would you do with the 3x plus 1? FOIL it out as well, and then combine like terms. Sounds like a blast, but I'm not teaching you algebra, I'm teaching you calculus right now. So, are we cool? So, derive, done. Are we cool? And now what we've done is we've used a product rule, and we've used the chain rule, and it didn't hurt us yet, right? All right. So, are we cool so far with product rule? All right, let me show you the next rule. I think you'll like this rule because I have an old lady trick that helps you with it. You might like it, you may not. This next rule is called the quotient rule. What is something that's written as a quotient?
Division.
Division, a fraction, right? Okay, it seems like it's horrible. I promise I might make it easy for you. Okay, so if you look at your bright colored sheet of paper, it is this. I think that's how it's written for you all. and you say to me, how in the heck did you memorize that so easily, Ms. K? Because we know you struggle with the memorization stuff. Right? I know you're thinking that. Having said that, I actually have a little jingle. Can't teach math without a dance or a song. So there's a little song that kind of goes with this, not song. You can sing it in your head because I do. And the one thing I want you to recognize is that this is the numerator. I'm going to call it the high number. And this is my denominator. I'm going to call it the low number. Are you guys cool with what I just said? However, I'm lazy, so I'm actually going to write this as high and low. It's quicker. All right, are we cool so far? All right, so how does this work? It is, this guy that's on the bottom is referred to as low. You guys cool? And then what's happening is we've taken a derivative, right? So it's low d high minus high d low all over low low. Low d high minus high d low all over low low. You can call it whatever song you want. I mean, I could sing it all day long to different tunes. But low d high minus high d low over low low, I don't even have to think about it. Low means the bottom guy. D high means to do what to the top guy? Derive the high. Minus, that's the most important part, minus high, top guy, d low, derivative of the low, all over low low. What does that mean? Multiply them together, right? Square it. What do you think? Good? Okay? No? Okay, I challenge you. X plus 1 over 3x plus 1. Without really thinking about the u and the du and all that, think about it as low d high minus high d low over low low, and see how easily it comes out. Low d high minus high d low all over low low.
No, I got it. I'm just taking a second to process.
You like my song?
Yeah.
I know. You want me to sing it. I know that's what you were looking for. How did it go? Did you sing? I know you would. Yeah? Low d high minus high d low all over low low. Here's a suggestion. I suggest clean the top. Don't clean the bottom. Don't foil out the bottom. We're going to do things with that. But clean the top as much as you can. So in this case, you have 3x plus 1 minus 3x minus 3 all over 3x plus 1 squared. So the x's cancel. I've got negative 2 over 3x plus 1 squared. We'll probably utilize it more in that aspect than the other. Did you guys use the low d high minus high d low over low low? Yeah, pretty darn cool. I mean, you can't get much cooler. Well, you could, but you can't. All right, I'm gonna give you one to do. Are we cool? Low d high minus high d low all over low low. All right. Okay, let's do this fun one.
Fun?
Yeah, they have it. Okay, so things that I want you to recognize when I did up here, low, I put parentheses around everything. Why? Because eventually you might have to distribute something through, you have a negative that you might want to put through. So parenthesize, put parentheses around everything. So low d high minus the high d low all over low low. How'd we do? Do you guys sing it? Low d high minus high d low over low low? I promise you'll never have to worry about it, think about it ever again. You'll go to college and people will be like, I don't remember how to do the quotient ruling, but it's easy. Okay, so if I was going to clean it up a little bit, I'm going to distribute that 2x through. That would be 4x squared plus 2x. This would be 2x squared minus 10, but I'm putting a negative through as well. So negative 2x squared plus 10 all over low low. And then combine like terms. So you have 2x squared So far, so good. Minus, plus 2x plus 10 all over 2x plus 1 squared. How do we feel? Did I teach you something that rocked your world yet? No, yes, maybe. Abby, where'd I lose you? I see your face, you're like, Did you not like the low D high minus high low low low?
Yeah, I think we.
Is that where I lost you?
Yeah.
Do you sing it in your head? Like, put a little tune behind it. No? That didn't help at all? Yeah, if I'm thinking about it as U, DU, and V, blah, 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 it gets all convoluted in there. Yeah, you gotta just remember, I'm old and I've done this a million years, so I could give you all the tips I got as I remember them. All right, so are we cool? Here's a question for you. Let's see how much memory you have. No? Can't even start.
I said, oh.
Let's just see how this goes down. Nobody wants to do it yet.
I'm ready.
I know you are. By the way, everything that I'm teaching you today is still paper 2. But of course you test it in paper 3 as well. So my paper 1, 2 people, this would be like a type of question on your test. My paper 3 people, this topic would be on your test, maybe a little bit at a different level, and I'll show you how that level happens. Oh, that's cute. Sorry. Okay, so here's what I want us to do. Find the equation of the tangent line, where x equals 1. What? Oh, let's remind ourselves. When we are trying to find the equation of a line, in this case a tangent line, I need 3 things to be successful in finding the equation of a line. What do I need?
X, Y slope.
X, Y, slope. What do I have right now? I got an X. Can I have a Y? How? Plug 1 in where? Right here. That's going to give me a Y. Then I would have an X and a Y. Oh, an X and a Y. How do I go about finding a slope? Take a derivative. Once I take a derivative, if I set it to 0, I'm solving for a stationary point. Don't want that yet. That's down the road. Yes.
Can you, the derivative is the slope of the line tangent to any point on.
Correct. So your derivative is the slope of any tangent line on that graph.
Okay, so if they give you a line, or like if they, or a graph.
Give you a curve.
So if they give you, and then you derive it.
I don't want to find the exact slope at what point.
Oh, okay, so that's the slope at that point.
What point am I looking for specifically?
Oh, and then you plug your point in with
When x is 1, right? I care about 1 only right now. Not that any other number matters right now, but today it doesn't matter to us. I derive it, I plug in 1, that gives me the slope. What if this question was changed up a little bit? Play the game with me for a minute. Oh my gosh, is it that bad? She's like, I'm done, I'm not doing this anymore. Okay, what if this question said, find the equation of the normal line? Then you go, okay, I need 3 things in order to find the equation of a line, an x, and a y, and a slope. I've got an x. Can I find a y? Sure, do the same thing. How do I find the slope of a normal? By the way, what is a normal? Perpendicular. So if I take the derivative, stick in the 1, let's pretend I get 4 for an answer when I stick in the 1. That would be the slope of a tangent. What would the slope of the normal be if 4 was my number that came out? Negative 1/4. And then what do you have to use in order to find the equation of line? You use my favorite formula. My favorite formula. Everybody should know my favorite formula. All right. Do you guys remember my favorite formula?
Y equals, yeah. And X minus X.
Yeah, I mean, everybody needs to have a favorite formula in life, and if this is not your favorite formula, it's okay. But, yeah. All right, so let's challenge ourselves. Now, that's old school. What we just talked about should have been somewhere in that cobweb up there, right? Should be somewhere in there. We're bringing it back. However, what makes this new? What makes this pertinent to what I'm teaching today? Product rule. Product rule. Yeah. That's what makes it new. So remember, a lot of what you learned this year, kind of what we did last year, except for I have to add a little fun twist to it. Product rule becomes our fun twist for this problem. Yeah.
Can you go to the bathroom?
You may. All right, so go ahead, product rule. Within those product rules, what am I doing for each of these derivatives? Derivative involves what here? Chain rule. Derivative involves what here? Oh yeah. Do I clean it at the end? No, because I'm plugging one in. Don't clean it. Just derive it and then plug my one in. All right, have fun for a second. Let's see how it goes. You can talk.
So what is a regular word, then I just use this one?
Does anybody want to check their derivative to make sure they're good?
This times
I did it up here.
Okay, cool, and I can.
Does anybody want to check it, make sure they're cool? Everybody feeling good about their derivative?
Okay.
So the derivative of the first, chain rule, the derivative of the inside is -1, times the second, plus the first times the derivative of the second. Feeling good?
Yes.
Sixteen times 3 is 48. Nobody wants to talk?
Yes.
Okay, thank you. You know I can't do those kind of things. Okay. So did you get your y value? Did you get 16 for your y value? Anybody have trouble with that? Okay, when you took a derivative and plugged the 1 in, did you get -16 for your slope? Yeah, I didn't clean it up. You wanna look at the derivative, make sure you're good with the derivative? And so what is the equation of the tangent line? It's going to be y minus 16 equals -16 times x minus 1. That, my friends, is an equation of a tangent line. You do not have to clean it unless I tell you otherwise. Okay, where did I lose you if I lost you? Yes.
Do we have to take like an opposite reciprocal or something?
If it was a normal line,
Oh,
if it was a normal line, the answer is yes, but it's not normal, it's tangent. Cool? There will be normals.
I'm gonna do that.
All right, everybody else cool? No? Yes? Yes? I love this stuff, Ms. Kay.
I get it, but I just,
Well, I'm gonna add to it.
32.
This is just the tip of the iceberg, I don't even know how to call it.
Oh, I did that.
Some people are like, please bring back hypothesis testing.
Actually.
And I'm like, yeah, crazy.
No,
Okay, our fun.
push one is fine. Push one is fine. Bring that back.
Okay, how do we feel? Should I go through you individually so we can talk about like, kind of like the, confessional? Are we good? Yes? We're good? Is anybody going, how did you get the -1 on that first thing over there? Anybody cool, like, we're good? I'm trying to make eye contact, y'all keep looking down. Are we good?
It's bad.
It's bad. It's bad. Okay, that's bad. You need a calculator. All right, do we need to talk?
You
Are
want
we
to borrow
good?
one?
Do you have an extra?
I didn't use mine.
So, 2 minus 1.
Did I make a mistake?
I got 15.
So 2 minus 1 is 1. Okay.
That's right, my second. Anyways, thank you.
Hey, good, I'm glad.
I did that too.
Definitely could happen. Yes. So you have to solve for y, meaning you plug in the original. On a good day, they give you x and y. Not on a good day today, I just told you what x was. And you need x, y, and slope. Good? Yeah? Yes. What is this? So it is the derivative first times the second plus the first, and then it's the derivative of the second. So the 4 came to the front, rewrote the junk on the inside, subtracted 1 whole, and then derived the inside. Did that help? Yeah. Okay. The junk helps. How do we feel? I feel like the tension in the room is there. All right, let's do this one. I'll know it's bad if 5th period is quiet, because 5th period is never quiet. He'll be like, find the coordinates of the points where this thing, where the tangent is parallel to the x-axis. Yeah, so if I'm parallel to the x-axis, put your arm the way it should look. Parallel to the x-axis, yes? What's my slope?
0.
So when I take a derivative of this thing, what am I gonna set it equal to? 0. So you're gonna derive it, set it to 0, and solve for x. So this is not new, however, the derivative here would be new because we are using what? what rule? Quotient rule, which has a cute little jingle involved. Low D high minus high D low over low low. All over low low. I don't know. I could make it any song you want to. So derive it for me. Put your eyes up here. Put your eyes up here and make sure your derivative is perfect. Did I just do it too fast? You know why? I went low D high minus high D low all over low. That's what my brain did that time. I sing it. No, I thought that's what you were asking. Low D high minus high D low all over low low. Okay, now here's the deal. If I know the tangent is parallel to the x-axis, you all told me slope is 0. What do I know about a fraction equal to 0? Fraction equal to 0. What goes away automatically? The denominator's gone. So what can I do? Once I set this puppy equal to 0, I can go, ooh, I don't care about the denominator anymore. Right? So I'm going to clean this up to the best of my ability. Right? So I'm just going to rewrite it and work it slowly. So, question for you. What should I do to clean this up? Like, I got some algebra now I have to do. What should I do this?
Foil.
Foil, and then do what with the 2? Distribute. Okay, so let's start there. Did I hear what the what? Check my math, because it could be bad. I'm feeling confident today. I feel like I brought brains over beauty today, so the brains are working pretty well. No?
Miss K,
Yeah.
what, maybe I'm doing my math wrong. Would that positive 2 on the right hand, wouldn't that be negative, or am I not distributing it correctly?
Okay, here, this thing,
Yeah.
should it be negative? Like when I derived it?
Well, no, when you distribute the.
Well, here's what my brain thinks.
Mhm.
Oh shoot, should I have squared that first? Well, there, I took beauty to school today, so brains. Well, shoot, that worked out really nice. Does it? Thank you, Lord. Yeah, say it again. I can listen and make a mistake at the same time.
Find the coordinates, would you put the x values into the original or would you put them into the
Original, good question.
Okay. Yeah.
Because I want to know the actual points on the graph. Well, that's good news. That was so beautiful how it worked out. I was so confident. I made a mistake. I mean, are we really surprised? Not so much. Okay. Wow. Yeah, it really does turn out nice again. Did you get -6 and 1?
Yeah.
Much better.
What did I do?
You guys are so sweet about it. So I did have a degree in math with a master's in it. That helped me a lot. Yeah.
Oh my god, I didn't.
I did the entire thing wrong too. Don't feel bad. Okay, so find the coordinates. Coordinates mean x and y. So I'm going to take -6 and I got to plug it right back into this thing. So when x is -6, is it 0? For the other guy? Oh, yes, for sure. That's a nice one.
Oh my god.
Is that what you got? How do we feel?
You're very fast, Miss Kay. Like you're very good at it.
I'm really good at making mistakes with confidence.
It's better with confidence.
Much better. Like I did it like sure, and then you're like, how is that happening? And then I went back to look, because Lord knows. So tomorrow we're gonna learn how to take the derivative of e to the x.
Okay.
Can I give you a sneak preview?
We're gonna do the sign
The
stuff.
derivative of e to the x is e to the x. And the derivative of e to the u is e to the u, and then the derivative of u attached. Watch. E to the 3x. Rewrite this. So tell me what to rewrite. Rewrite this. E to the 3x. And then what's the derivative of the exponent? What'd you say? Just attach it to it. That's your derivative.
Why don't we do that today? That was a little easier.
Well, we're going to do it like then tomorrow I'm going to have e to the x times x plus 1 squared. Find the derivative. And it gets better. Yeah.